Okay, so this is the one I said that I have managed to lose the PDF somewhere in cyberspace. So just go ahead and you can either maybe cut and paste and pause. I'm going to go ahead and show you the whole thing first. So pause and maybe copy down some problems, or you can do this a few problems at a time and then watch the key for those problems, however you want to do it. Again, pause yourself. Make it go the speed you need it to go. Okay, now here's the key. So let me just show you the actual key, and then I'll show you the actual work. Here's the key. 1 through 8 are the type where you're just putting one side over another. Okay, these are the fraction answers. Remember, if it asks for decimals, you just change those to a decimal by dividing. Like 9 divided by 41. You don't press any sign buttons or anything. Okay, here are the answers for 9 and 10. This is finding missing sides. So are 11, 12, 13, and 14. Then you get to finding some missing angles. And finally, here's another of the equilateral triangle problems. Okay, numbers 1 through 8. Like I said, this is just a matter of, for instance, on number 1, you find Z, decide which side is adjacent and which side is hypotenuse. And then this must be the opposite. And so for tangent, I'm going to put opposite over adjacent and then simplify. So that's all I'm doing on these. If it asks me for a fraction, a decimal, remember, I just change it to a decimal by division. 3 divided by 4, that would give me 0.75. I don't really need approximate there, that's the same thing. Okay, so that's all you're doing on 1 through 8. Let me just show it to you in a different way though, because it's possible you'll see it in a different way. For instance, what if you saw a triangle and it said, here is triangle ABC, and all 3 sides are given, and you are supposed to find the sine of A, the cosine of A, and the tangent of A, and then you're supposed to find the sine of B, the cosine of B, and the tangent of B. Okay? I would go ahead and label everything for A first. So here's A. Hypotenuse is going to be the same no matter what. You might want to make sure you're using pencil for the opposite and adjacent if we're about to change from A to B. All right, so for A, 3 is the opposite, 4 is the adjacent, and 5 is the hypotenuse. So the sine would be opposite over hypotenuse. That would be 0.6 as a decimal. The cosine is adjacent over hypotenuse. That would be 0.8 as a decimal. And the tan would be opposite over adjacent, which would be 0.75 as a decimal. Then we're going to have to get rid of this labeling of adjacent and opposite because I'm going to go look at it from the other angle. The hypotenuse does not move, but the adjacent and the opposite swap. Okay, so this becomes the opposite and this becomes the adjacent. Now the first thing I want you to notice about this is Since sine is opposite over hypotenuse and cosine is adjacent over hypotenuse, if we trade the opposite and the adjacent when we go from one angle to the other, we're basically trading the sine and the cosine. In other words, the sine here is 4 over 5. That's the sine of B. Notice the cosine of A was 4 over 5. So the cosine of one angle is the sine of the other angle when we're talking about the two acute angles. Not the right angle, but the two acute angles A and B here. So if the sine of A, was 3 over 5, that will also be the cosine of B, adjacent over hypotenuse. 3 over 5. Okay? So the sine of one acute angle is the cosine of the other one, both ways. Okay, these are the same, and these are the same. How does the tangent change? The tangent flips over. When you flip something over, it's called the reciprocal. So instead of being 3 over 4, it'd be 4 over 3. Okay, so back to the worksheet. Numbers 9, 10, and beyond, this is finding the missing side length. So for instance, for number 9, let me do it on the one that doesn't have the key. The two sides of the 60-degree angle are 17 and x. X is the hypotenuse. 17 is the adjacent. So I'm going to write a cosine equation. Cosine of 60 is adjacent over hypotenuse. When you cross multiply, you get this. And this is what goes in my calculator, 17 divided by cosine 60. Notice I'm not finding the angle, so it's not inverse cosine, it's just plain cosine. And I get 34. So that's 34. Don't forget, please, if you are solving the triangle, that means keep going. I would now find this side, probably Pythagorean theorem, 17 squared plus this side squared equals 34. And the easy thing is finding the other angle. If you know one angle, the other acute angle is just 90 minus that one. So 90 minus 60 gives me 30. Look at number 10. Here are the two sides of my 34-degree angle. One of them is the hypotenuse, one of them is the adjacent. So that makes x the opposite. So if I'm going to work with the x and the 14, that's opposite over hypotenuse sine. So here's my equation. When I cross multiply, I get this. That's what goes in the calculator. 14 times sine of 34 should give you 7.82. It says round to the nearest tenth, so x is 7.8. Every time you do this, please make sure you're not supposed to go on. Make sure it just says, okay, just find the missing side. If it says solve the triangle, you got to keep going. I'm going to give you another Easter egg. Here's your other Easter egg word. All right, so 9 and 10, you keep doing the same thing for 11, 12, 13, 14. 15 through 20, finding missing angles. This is where I actually use the inverse, but I don't worry about that until I've got it set up. Okay, so here's my angle. That's hypotenuse and adjacent. So that's going to work with the cosine. Cosine of my angle, I'm going to call it x, equals adjacent over hypotenuse. So I'm going to do the inverse cosine to get the cosine away from the x. So x equals inverse cosine of 53 over 60. And in my calculator, I'll press second cosine of 53 divided by 60. And I get 27.95, which is about 28 degrees. So that's my answer for number 15. Again, if I needed to, I would keep going here. Maybe I would find this side up here with Pythagorean theorem. If I knew this is 28, I can find this angle now by subtracting 28 from 90, and that gives me 62. So if it says solve the triangle, you have to keep going. If it just says find the measure of this angle, then I've done when I get to the 28. Number 16. Here's my angle. That's the adjacent and the hypotenuse. And that's the opposite. The two sides I have here are opposite and adjacent, so I'm going to use the tan. The tan of x equals opposite, which is 19, over adjacent, which is 46. If I want to find the x, I got to take the tan away from it. So x equals inverse tan of 1946. It's 19 over 46. So inverse tan, that's second tan. 19 divided by 46 is 22 degrees. Okay, we've done several of these, but let me just do one more real quick. Okay, if this is 3, this is 3, this is 3, this is supposed to be an equilateral triangle. Here is the height. Half the base then would be 1.5. This is a 30, 60, 90 triangle. And I multiply the short leg times square root of 3 to get the long leg. I'm not really concerned with how to write that because I'm about to use it. I'm more concerned with using it. So area equals 1/2 base times height. Make sure you use the whole base. Okay, so 1/2 times 3 times 1.5 times square root of 3. And that gives me, drum roll, 3.89 or 3.9, about 3.9 square kilometers. Custodian's about to vacuum in here, so I'm going to wrap it up pretty quickly and say that your last Easter egg word is pumpkins. Thanks for watching.